Okay, in an effort to try and keep this video short, I'm going to move fairly rapidly, but you can pause it and go back over it, okay? So bear with me, please. So two different methods of solving system of equations algebraically. Method one is called the substitution method. And if I look at example 1, it's a pretty simple type. I have y equals 5x plus 3, y equals 4x plus 4. I want to solve that system. And substitution means we're going to substitute one of these in for the other. So since y is equal to 5x plus 3, I can replace this y with 5x plus 3 and just set these two equations equal to each other. I'm substituting this in for that y. And when I set them equal to each other and go through the solving of this, you're going to come up with x is equal to 1. Now, take that x equals 1 and substitute it into either equation. Okay, you should actually do them in both to see if you get the same value. But I'm going to take the 1 and plug it into the top. 5 times 1 plus 3 is, in fact, 8. And that tells me these two lines have a solution for the system at 1, 8. And that means the two lines are intersecting at 1, 8. That's very important to me, that you know that the solution to a system of equations is where the two equations intersect, where they coincide, where they are the same. Two lines can intersect at one place or an infinite number of places. And if I just demo that real fast, here's a line. Okay, here's a line. They can only cross once. Or, this may seem stupid, but this happens. If they're exact same line, I graph the two lines together like that. That means there's an infinite number of solutions. So that can happen. When there's a solution, we say it is consistent. When there's one solution, we say consistent independent. And that's just terminology that you'll see. So I'm going to go to example 2. So we get on there. Okay, example 2, here's my system. Take the simplest equation and solve for one variable. And simplest would be this one because there's just a 1 in front of the x. So if I take that equation and solve it for x, that's what's happening here. I get x equals negative 3y plus 17. I'm now going to take my second equation and substitute this here, negative 3y plus 17, in for that x. And that's what's happening here. Now I'm not going to step you clear through that, but as you solve that, you get y is equal to 5. Since y is equal to 5, I can place that into either equation. I took the more complicated one. The smarter play is to use this one, but I just to show you, I'm going to take this one. I'm going to put 5 in there, and I'm going to solve that. You get x equals 2. I'm going to scroll this up. That implies the two equations intersect at 2, 5, because that's the coordinate I found. And again, it's consistent independent. Method 2. Method 1's great. Don't get me wrong. Method 1 is something you can always go to, but it's not always the most efficient. If I have both equations written like this, where x and y are on the same side, elimination is typically the faster way of going. And this example is going to motivate that. If I take these two equations, which I have rewritten here, and just add them together vertically, what happens to the x's? Well, they're gone. 3y and 1y is 4y. 17 and 3 is 20. And when you solve for y now, you quickly get y is equal to 5. Go back to one of the other equations, this one probably, plug in that 5, solve it, you'll get x is 2. So the solution is 2, 5, it's consistent independent. But the idea is, can I manipulate these equations so that when I add them together, I eliminate a variable? Well, here's another one. X plus 7y equals 8, 5x minus 2y equals 3. I can't just add them together and get rid of a variable. But can I take that top equation times something so that when I add them together, the x's are gone? And we could work with the x or the y's, but in this one I'm working with the x. So if I take this top equation times negative 5, and I have to do it to both sides, that's what I'm writing out here. Okay, so pause it, check my work. And when I add them together, the x's are eliminated, and the negative 35y and negative 2y add up to give me negative 37y. Negative 40 and 3 gives me negative 37. Y is equal to 1. Substitute this back into either equation, and x is 1. The solution is 1, 1. That's where the two lines intersect. It's consistent independent. And a couple things to think about on this, when I'm doing these examples, when I give you a test most of the time, okay, these are going to work out to be nicer numbers. My math lab, they could be fractions. So you might have to deal with fractions when you substitute back in. Example 3, I'm not going to go through this one. I just made it up for you to practice right now. Take the top equation times 2, add them together, see what happens. You should get 2, 1, and that'd be consistent independent. Okay, example 4. Again, look at this yourself. You should be looking and thinking, oh, what can I take this times to get rid of something? Well, -2, that'll probably work. That'll get rid of the y's. And when I take the top times -2, add it to the bottom, you come up with all this becomes 0, all that becomes 0, 0 equals 0. And that means something. 0 equals 0 is true, and I didn't write that here. But since that's true, that means there's an infinite number of solutions. And that would be a consistent, because there's a solution, dependent system. And geometrically, that means the two lines are really the same line. They're being graphed right over the top of each other. So I kind of need you to know that idea. Example 5. Very similar system. It's a little different. I changed one number in that. If I do the same thing, if I take it times -2 on top, I get that. And when I add it together, the left-hand side still is 0. The right-hand side becomes -4. The 0 is not equal to -4. That's false. Well, when it's false, that means there's no solution. And when two lines never intersect, they're going to be parallel, correct, in the plane? So I know those lines are parallel. How do I know? Because there's no solution. The only way there's a solution is if the lines cross or lines are exactly the same. So this would be an inconsistent system since there's no solution. Now, I know I went fast. Pause it as you need. Go back through it. Work your way through it. And we'll hit the ground running with this in class tomorrow.